modules to the kernel, you have to use the sudo. You just need the sudo permissions.
Okay, got it, got it. Yes.
Yeah.
Sir, I have one doubt.
Hi, Dhruv. Yeah, please go ahead.
So, does creating containers of virtual machines and all that also comes under embedded part?
The virtual machine is the machine you're like utilizing some portion of space from your disk and creating the machine. Okay, so yeah, so why not? Like the it is like depends, right? So the machine, virtual machine is of Windows, which machine you are configuring. If it is of Windows, it won't be like for embedded applications we use Linux. Okay, so if you are creating the virtual machine for embedded applications, so there will be running the Linux. Okay, so depends on the Linux, depends on the OS we are using on the virtual machine. We can say it.
Okay, sir.
Mm. So for the exam and the interview, how many guys are interested? So that I just want to check whether people have understand the content that we have shared last day and the day before yesterday. So I just want to recheck.
Sir, WhatsApp group has not been created. When
Yeah,
will
I
we be
last
attending?
last day I have checked with what's like I have checked with Prashanti last day. She what she said is like the people who are like some people are there like they've been sharing some sensitive information from ProV Logic outside. So that's why she's thinking some other way to integrate you guys and me and Prashanti in some other channel rather than going with the WhatsApp.
Okay, sir.
Sir, create any community is better.
Community? What is that?
Like in WhatsApp also creating the some.
Okay, okay. Yeah, yeah, yeah. In WhatsApp community. Okay, okay,
Yeah.
okay. Any other question? So raise your hands for the people for the exam. Okay. Till this point, you have asked me some questions, right? So here are the questions from my side as well. I'm just gonna ask you the guys. Uh, so the my first question for you guys, why what makes you to choose the embedded Linux? I just want to hear your passionate answers rather than like you might be knowing the how powerful is the Linux, and so in like while seeking career on such a powerful thing, what makes you to choose the Linux? I think Dhruv is into bare metal stuff. He's been working on ESP32. But what makes him to choose the Linux over the STM or like ESP32? Can I start with Dhruv?
Yes, sir. So,
Yeah, share your experience with the people. It might be helpful.
so I started with cybersecurity. The cybersecurity was the one that moved me towards that bare metal thing. And when I learned the limitations of bare metal, that's what got into my embedded part. As I got to know that Linux is such a powerful operating system and kernel,
Okay.
that was the main reason I started learning about embedded part. So that such miniature devices can run servers and all.
Yeah. So, have you found yourself limitations on while using the bare metal controller, or you found passion towards Linux just because the powerful activities that were performed on the Linux is that motivates you, or like you found yourself as limited to so because when we are working on limited stuff like STM or microcontroller stuff, we will be limited for such applications. If we just rewrite the code for some other applications, we can dev we can develop anyhow. But when we are writing for the specific application, the company offers only one feature. So if we are working on that feature, it would be limited, isn't it? So our job will be like every day. We don't need to. We have to check for the bugs and also all the time. If there are no bugs, how we are promoting these features to the next level. That is how it works, right? So when it comes to the Linux, it is like anything. We can do whatever we wanted to develop. So if you are into the cyber security, we can implement the security features. If you are into something like IoT, you can utilize the Linux kernel for anything, any job. If you want, if any hardware is developed on the, if any new IP is introduced onto the hardware, you can develop the hardware drivers. So that's where like you can have multiple areas of freedom, areas of departments you can excel. Suppose I can say like mine is like I'm interested in cyber security, so that like I'm interested in writing secure kernel secure drivers, or like that might be the thing. Like if people are into the network sort of thing, people will be looking for writing network drivers. So that is where like it will gives you multiple choices among to work on, right? So the Linux is a pretty a decent way in terms of seeking the career. You can switch anyhow, like the driver, how actually the skeleton is similar. Whatever the driver, irrespective of the driver you're developing, for all the drivers, the skeleton is similar. Okay, so like for example, the car. For example, if you just consider three cars like Mahindra and the Tata and the Suzuki, if you just consider these three cars on the platform, the skeleton in the sense like it will have two headlights, four tires, and one steering and four or five seats. And the skeleton is same, right? But the design, the way we look at the car, the designs, the vendor, like the company attracts the people is different. That's where like every people creativity comes out, isn't it? So the skeleton is simple, and on top of the skeleton, how you are like calling the APIs, kernel APIs, and how the features are implemented, that matters a lot, isn't it? So uh, you can choose your career in what I want to say for the young people, the fresh blood like you guys is don't find like comfort in terms of earning money or something. Like if you can able to earn money in the Linux, it doesn't mean like for money we are working. It mean like it have to be like we want to we are learning Linux just to make ourselves creativity, and it have to be passionate. Don't work for something like okay, from 9 a.m. to 5 p.m. This only my job, and so if I done my responsibilities in this time, I don't dedicate my rest of the time to the Linux in terms of learning the new stuff and all. So don't be like that. So it is your opportunity in terms of learning, as it is the Linux, you have wings to explore whatever concern departments in the Linux, like security or network or like crypto in terms of developing the hardware integrity. You know, that matters a lot. Okay.
Yes, sir.
Yeah. It might be late for someone to get job into their respective domains, but the journey we've been through is really important. I know it sounds awkward for you guys when you're seeking for the opportunity into the industry, but that's really important for the people like you guys, you know. So if you're like not doing the job from 9 to 5, you will be having some good amount of time to learn some new stuff and all. But when you guys are working from 9 to 5, you will be having the limited time, and there are not great opportunities for you to explore a bit more regarding these stuff. Okay. So how many of you guys are from CSE background? None? Dristy, are you from CSE? Any questions? Hello. So, I will explain about the Linux source tree again, because this is really important for you to just, you know, understand how what actually where what components and what are the directories about and what components are in there in that specific directories. Okay, so this is where the arch is nothing but the architecture and all the hardware specific, you know, last day I have said like the BeagleBone we are working on, right? So if you just go to the ARM, and in the ARM you will be having the def config control if like AM 335. What's the def config we have here? So here in the ARM, you can see OMAP, uh, or else MediaTek, you might be knowing it, right? So it's a processor design company. So uh, Here, OMAP is the one, it will be used for the hardware. Like these all are the configs that are there. It would be defined by the specific vendor. Okay, vendor, sorry. So this is how they define, and the configs, if you just go there, just give me a moment. I'll just go to the configs. Here, if you just go OMAP 1 or what is that, AM3, three. Yeah, so multi V7 config. So this is the def config we use for the uh, BeagleBone. Okay, so this is the multi V7 def config defined by the Texas Instruments for the BeagleBone especially. So it has a V7 architecture based on ARM. So they have designed it. Okay. So when you are compiling the so based on the architecture, if you just go down to the ARM, and inside the ARM, if you just go to the configs, so you just have to check for V7 def config is defined over there. So multi V7 def config is the config we have used for the BeagleBone. Okay. So by making this def config, the dot config will be configured for the BeagleBone Black, so that like all the configs will be written over there. Okay, these all are the configs we have. So these are like based on why I have said right here. If you state here as a y, it will be statically compiled with the kernel module. Okay, kernel at the time of kernel compilation, this I2C OWL will be included in the kernel itself. When you have stated it as m in the configs, it will be compiled and it will be loaded into the rootfs, so that it will be there in the slash lib slash modules slash the kernel version. Over there it will be loaded into the rootfs, and at the time of booting it won't be loaded as part of kernel, but these will be loaded as part of kernel. So whatever the modules, whatever the configs we have stated here as a y, those will be loaded as a part of static kernel. Okay. So whenever you load, whatever the components you have stated as a y, those will be the part of the kernel, and for the things you have stated as m, it will be there in the rootfs. You have statically probe these things, so dynamically load these things by using ins mod or mod probe, and you can remove that from the kernel by using rm mode. Okay. This is all about the architecture, and that is the significance that the arc possess with. And if you just close it, we have here the block. You might be knowing on a very cascaded way. I will explain you. So the block drivers, it will give you. You might be knowing FAT32 and FAT16, EXT2, EXT3, EXT4. Such type of file systems are there, right? So all those sort of algorithms are defined in the block. Okay, so the block will consist of the algorithms for the hardware architecture. For each and every hardware architecture, the algorithms are defined here in the block. Okay, so that is where, like, if you want to develop the block drivers, so the block drivers like MMC or SD, these all are called like to handle MMC driver. The MMC part comes under the block devices. So to handle that one, the block drivers are needed. So like that, it is differentiated. And if you just close it, we have certifications here, certs are there. And so I'm not going into the certs. I'm just going to the crypto. crypto is the thing like here the keys are there, right? Okay, if you just consider the secure boot concept, that is really really important for your interview process also. Okay, so the secure boot is like when so the trusted firmware will be built, right? So the system have not to be compromised at any point. So suppose like if your system is running with some sort of Linux which is not secured, so the hackers will if they change the integrity of the boot firmware, if they have written something in the boot, like the system will be compromised, and the malware sort of malware introduced firmware will be running on top of your hardware. So the hardware, there are lots of chances in terms of hacking your hardware, isn't it? So the system has not to be compromised at any point of time. So for that, the secure boot is doing like they develop the secure boot. So all the algorithms like hash, if you know, if you just created a file, that file will be having some content into the file. So based on the content, the algorithms are there, like a SHA algorithm is there. SHA-256 or like asymmetric keys, and so such sort of things are there here. These will be created the secure keys when it is exchanged from one stage to the another stage. If the key matches, then only the booting will be happen to the next stage. Suppose the boot ROM will be having the hash sum of the FSBL MLO. So when it loads the FSBL from the eMMC or SD card, okay? So the time it will check the hash sum of the FSBL while it is loading, okay? If it matches with the hash key that has there in the boot ROM, then only it will load that FSBL into the DDR, or else like it will hangs the process over there and it will be like restart again. It will ask you to install the required first FSBL or MLO. Then the MLO will once the MLO is loaded, and once it is looking, it will bring the U-boot from the position that is defined, right? So when it is pulling the U-boot from the same SD or MMC, EMMC, it will check for the SHA value of that U-boot value, and so the FSBL will be having the SHA value of at the time of compilation only. The values will be shared among the next stage artifacts values with the current values. Okay, so like the way in the firmware, in the boot ROM, all the values, SHA values of FSBL will be given, and it will check with the FSBL SHA value. If it matches, then only it will be loaded into the DDR. In the same way, FSBL will check for the SHA value of the U-boot. Then only if it matches, then only it will load into the DDR. In the same way, the U-boot will also calculate the SHA value of the U-boot next to kernel image. Once it matches, so then only it will load into the kernel. So in such a way, this is called the secure boot mechanism. Okay, any doubts here? This is how the crypto is nothing but like how the security sort of keys like keys are generated, and this is like some sort of security features also implemented in the crypto. The drivers, this is where the Linux whole kernel code comes into, right? Okay, this is where the actual communication with the hardware and the kernel software will happen here. So these part of drivers are responsible for handling the communication among the real hardware and the user space applications. These drivers, whatever the drivers we define here, the Bluetooth, the block drivers, so like aux display, and ATM, AMBA, Android ACPI, and CAD drivers are there. So CPU frequency. So these all are the drivers that we have here. So these all are responsible for establishing the communication between the hardware and the software. So this is how it works. Okay. So the drivers plays a major role in terms of establishing the communication between the hardware and the software. So if you guys wants to seek your career here in the drivers, that is really really great in terms of good career you will be having. So here you see like net is there, network drivers are there. Okay, so if you just go to net, so here the network drivers are there. So the network drivers like Ethernet is here, so it is responsible for establishing the the IP address plays a crucial role in terms of internet connectivity, isn't it? So the MAC address is the physical address of our hardware it will be having, so that like based on the IP, it will take to the outside servers, it will connect to the outside servers, and the communication will happen via IP address, right? So this the whole IP address assignment will be, and the whole communication over the internet will be happen with this Ethernet encapsulation and decapsulation of network layers will be done from Ethernet itself. So this is a really, really great driver on the Linux part of things. So if you got the chance opportunity to work on Ethernet, you are really it's a great opportunity for you guys. So okay, so this is how the network driver is, and if you just close this network driver, NVMe, it is like PCIe. Okay, so a PCIe nowadays it's booming. So PCIe is a private expressway between the hardware component like hardware accelerators or like GPU or SSDs. If your laptop is having SSD, solid state drives, you know. So why they are quick means like in terms of sharing the data among the hardware components on the SSD, they it will be having separate physical private expressways there rather than going with the system bus. It will send the data from this private express, so that like it will send the data like at any force at any quick way, so it will be sending it. So the PCs are booming right now. So even if you want to seek your career in PCIe, it's all about you. The performance drivers are here in the perf. So like that, they have defined here. And SPI is the driver you will be knowing your initial days. Okay. So USB is the driver you for handling the USB devices. So if you just plug your mouse or like any USB device to your laptop, so it will be knowing to the kernel, right? So the kernel will identify. It's a hot plug, you know. Whenever the moment you just plug your device, the kernel will be knowing it. Okay, some some pen drive or some card reader or something is inserted at the USB socket, so that it will be the what sorry the USB driver will take care of that one. So the video drivers are there. So video in terms of playing the video on your screen, you know. So there are video drivers are there. So this is the watchdog. It's really important stuff to know. The watchdog is like whenever if you are this will send some reset signal to the system all the in fixed intervals. If the system responds to that reset, you know, it is okay. If it is not, doesn't respond to the reset, you know, the system will be hang up because it will be thinking that system is like compromised in terms of integrity. So it will just reboot. Okay, so it is also a security feature. The watchdog, you can expect it in the space applications mostly. So in the space applications, I'll explain some example like, you know, um, uh, guys, hello, hello, hey, someone respond, man.
Hello. Yes, you are audible, sir. Yeah.
Yeah, so you can able to understand it, what I'm trying to say.
Yes, yes.
Okay. So in the space applications, if you just go and if you can able to uh, suppose like we will be monitoring the space things, or from suppose if we send our robots to like we have to send our satellites and something like that to the space, right? So in the spaces we'll be having our microcontrollers or microprocessor running over there. If we like the watchdog will be indication that like so it will be so there is no one to monitor the system, right? So the time we will be writing some logic to the watchdogs indicating that you have to send your reset signal in the fixed interval. Suppose for every 5 minutes or 10 minutes, you have to send the reset signal. If the system is properly working, it will like respond to the reset signal. Okay, I'm doing good. Don't need to panic. Okay, so don't need to restart the system. I'm doing good. That's the acknowledgement given by the system. Then the watchdog timer will never restart the system. Okay, so like the signal that was transferred, that was given by the watchdog, will be acknowledged by the system in such a fashion that I'm doing good, don't do the reset. Okay, so hard reset will be done if it doesn't respond to that signal. Okay, so that is the way we are checking it. Okay, the integrity of the system, we will be checking with the watchdog in such a way like that. And yeah, this is all about the drivers I want to give you. I want you to understand. Okay, and if you just close these drivers, and the next part is mm, just give me a moment. It's a big thing. Okay, file system. So the file system, it's like, file system algorithms are defined here. Whatever the file system algorithms are there, it is defined over here. And the include is important thing. Whatever, suppose like in the Linux, if you just go to the source code of any driver, there will be like Linux include sections will be there. Hash include is there, right? So whatever the headers that we defined in every driver, that is part of this include part only. Okay, so the kernel APIs or the Linux APIs are defined in this include section, so that it will be there. Okay, so that is all about the include. When it comes to the init, so the init is an important process in terms of Linux bootflow process. Okay, so once the Linux is booted, and the first user space program that runs on the system is like this only, init. So slash sbin slash init. This is the process that will run in the user space. This is the very first process. This will be having like the user ID, the process ID as 0 or 1. So this is the first running process on the system. It will enables it will sets up the IP address for the system. It will also like sets up all the user space things. It will enable all the hardware is enabled at the bootflow process itself. Whatever the user space utilities it needs, it will be enable all. It make the system to be ready for the user to come and use. That is what the simple job of init process. Okay, so the IPC is another important thing to consider. So the kernel is the process. The kernel is the master. So in terms of like process, suppose if you, for example, I can say here, what's the sort of usage we have IPC here. It's an inter-process communication. So how inter-process communication works is like suppose if you guys are using smartphones nowadays, so if you just request an OTP, it will be like, so suppose if you are doing some payment, so it will send an OTP to your phone number, and that OTP will be captured at your text, on top of the keypad, and the place where we enter the OTP, it will be displayed over there, right? So such sort of communication. So the OTP was sent to your messages. From messages, it was like it will be displayed to you at the from top notifications you can able to see, or else you can also see that in the suggestion box you can also able to see the OTPs, right? So that is what a simplest way of inter-process communication happening. So at the user space level, so when one process depends on another process response, so when such type of dependency is there, we'll implement this dependency with the inter-process communication. That is, inter-process mechanisms are defined here in the IPC directory. So we have multiple inter-process communication mechanisms like system queues, shared memory, and message queues, and for inter-process communication. And the kernel, this is the main source code for the kernel. And if you just go to the kernel, in the kernel, the scheduler is there, and the main code that the source code of the kernel is defined here in this code. All the scheduler policies and all the scheduler algorithms are defined here in the kernel. And so network algorithms are defined here. This net is different from the net that are there in the drivers. So here the network algorithms are defined, and there the network driver code is there. Okay, so security algorithms are defined here in the security and tools. So tools are the user space utility. Suppose if you just know IIO event monitor is there. So that is like event monitor. When the system monitor is another like another important utility. So like a system monitor in the sense the temperature, the CPU temperature and CPU voltages that would be calculated by the system monitor, and it will be displayed to the user by user space utility like IIO event monitor. Those sort of things are defined here in the tools. Okay, so if you just go there in the tools, you will be seeing uh, all these like GPIO. In the GPIO, you have multiple GPIO watch, GPIO utils. So so whatever the things we have connected to the GPIO. So to utilize the GPIO binaries, that are there, that are defined in this GPIO. Okay, so these are like user space utilities. Tools are like something. So if you just go to, if I just close it, and if I open IIO, so IIO is like a event monitor. So so here, if you just see IIO event monitor is there, it is responsible for printing something like temperature, the CPU temperature, and the system temperature. So those sort of things will be monitored, and it will be shown to the user by this IIO monitor.c. Okay, so this is the way it is works. And if you just go to sound utilities are there, time. So all these things are defined over here. Okay, this is the utility tools thing. And yeah, basically, I gave you a great understanding. I think this is enough for you at this sort of understanding. Okay, so at this level, I gave you pretty much understanding regarding the Linux source tree. And yeah, you are welcome to ask any questions now.
Sir,
Uh,
this rootfs and the file system you mentioned are entirely different, right?
yes, 1 second, 1 second. I'll explain the difference. I have just failed to send, right? Okay. Okay. Shafir or someone is asking question. What's that?
Yeah, like I just want to know that rootfs and the file system you mentioned, like ext4, ext3, all are different things, right?
Yes,
Both.
yes. So the rootfs is the root file system. You can see the slash. Okay, the slash is the root file system. It is of like ext4 most probably, and you can see like suppose you can say MMC is there, right? eMMC or SD. You can format that the way you can format. Okay, so you can format it to ext4, ext3, ext2, FAT32, FAT16. Such a way you can format it. Those all are the algorithms. Okay, so for booting the boot images we store in a way like it needs FAT32 or FAT16. We usually use fat what's that, like fat partition fat file system for booting the images, boot images. For the root file system, use ext4. So, for you guys to just want to know the difference between the each and every architecture, so the purpose is different. So ext4, uh, I don't want to give you some sort of small, like a minimalistic understanding about that. If you guys can, if you are interested in terms of knowing the differences among these file systems, you can just Google it or just go through ChatGPT and find it. Because those are like the signatures for the specific applications we want to use. Okay. So based on the signature, based on the application, it would be decided. The signature for booting is like a FAT16 or FAT32 we use, basically to store the images. If it is of rootfs file system, it would be like ext4.
Okay, sir. Clear. Yeah.
Yeah. Any other questions? So,
So
like,
how
yeah, please, yeah.
how will we be getting a participation certificate?
Yeah, you can ask those questions to Prashanti. So, Prashanti will share you that. So you know her number?
No, sir.
ఎస్ సార్. బట్ ఇంతమంది సడన్‌గా మళ్ళా మెసేజ్ పెడితే వాళ్ళకి రెస్పాన్స్ లేట్ అవుతది సార్. అయితే కమ్యూనిటీ పెడితే అందులో మన ఛాన్స్ బెటర్.
Okay, so you know, I don't know. She haven't joined the call, but she said like she gonna do something different than creating the WhatsApp group. I don't know whether it's a community or something. Okay, so if you guys like have the ProV Logic number, you just send hi to that number. I'll inform her that so the people who are interested, if they are sending hi, and send them like we are interested in embedded webinar or something like that. So if you just send that, she will contact you guys, and so she will talk to you. Send her WhatsApp. Like you guys have the WhatsApp number for the ProV Logic? Or else like I can't able to send that here. Can you able to see my screen?
యెస్ సార్.
So here in the chat
Yes,
box,
sir.
I have typed the number. So just take this number and send her hi. I can't able to send her. I don't know what's the reason behind it. If you don't have any questions, I'll drop off now.
సార్ ఇంతకుముందు తినడానికెళ్ళాను సార్. ఎగ్‌తో ప్రాపర్‌గా చూడలేదు. జస్ట్ ఒక డౌట్ ఉంది.
Okay.
అంటే నార్మల్‌గా ఎగ్‌తో అనేది యొక్టో లైక్ డైరెక్ట్ ప్యాకేజ్ ఇన్‌స్టాల్ చేసి అందులో యూజ్ చేయడమా? అది ఎలా ఒకసారి రిపీట్ చేస్తారా సార్ వన్ టైమ్ ప్లీజ్?
Yocto నా?
యెస్ సార్.
Yocto అనేది దేనికి వాడతామని చెప్పాలా?
అదే. యెస్ సార్. కస్టమ్ లినక్స్ క్రియేషన్ ఐ నో. బట్ అది ప్యాకేజ్ అనేది డైరెక్ట్ లైక్ లినక్స్‌లోనే ఇన్‌స్టాల్ చేసుకొని యూజ్ చేయొచ్చా? లేకపోతే ఎలా అని అడుగుతున్నాను.
We will be having the recipes, right? So within the recipes, we will be asking it to fetch the source code. So it will be fetched, and whatever you want to do the changes, you will be. So we have if the recipes are there. So along with the recipes, .bb append something is there, right? So within the append file, whatever the changes you want to do, if you have any patch for the source code, if you have, so the link for the source, the path for that source code you defined in the baby append. So at the time of compilation, these sort of like changes what we made for the source code will be applied to the actual source code that it have cloned from the upstream. So then at the time of building, the changes that you have made will be applied to the source code before compilation. Then it will compile the feature for you. You got me?
Yes, sir.
So, what's your specific question? Suppose if you just tell me, if you just give me the context a bit more clear, I'll give you understanding a bit more.
అంటే ఎస్టర్డే ఏమో మీరు చెప్పారు కదా ఫిజికల్‌గానే బోర్డ్ కనెక్ట్ చేసి బ్యాంగిల్ బోర్డ్ చేశారు కదా! సో, దీనికి గూడా అంటే ఎక్టో అనేది సెపరేట్ ప్యాకేజా? అది ఎలా అంటే ఇన్‌స్టాల్ చేసుకోవడం అంటే ఎలా
Okay,
యూజ్ చేయడం అని
okay,
అంటున్నా సార్ నేననేది.
okay, okay, okay. So, 1 second. Okay, so Yocto is something different than uh, you can build, suppose for the system to boot, what are the four essential components I said? U-boot, MLO, like a first stage bootloader, U-boot, and kernel image and the root FS, right? So these four components you can build, you can get the source code from internet, right? So FSP, with the U-boot, if you just clone the U-boot, you can get both FSPL and MLO here. If you just download, if you just cloned the root of kernel source tree, so then you'll be having the DTB and the kernel image. Okay, so and for the root FS, you have like you can get the root FS, raw root FS in terms of tarball file, or like you can get it in a zip file. You can get it. You can straight away download that from internet, or you can build it with some Debian command, Debian root FS, Debian based root FS. You can build it. Okay, so this is how the conventional. This is the normal procedure how you are building. So if you made some changes in the kernel, suppose if you have developed the changes here in the kernel, okay, so the kernel, this the things like you just have to manually build the U-boot and the MLO by building the U-boot. Okay, you have to manually build the kernel image, and you have to manually build the root FS. All the things are here manually. Okay, so the manual sort of things are happening in terms of source code cloning, and in terms of bit baking, in terms of building each and every artifact, boot artifact, you are doing manually. Okay, what actually the Yocto is, it's a package. Okay, so BeagleBone, sorry, in the Yocto, sorry, in the Yocto, how it will work is, so if you define some XML manifest file is there. If you define whatever the recipes, whatever the source code in the file, what source code, which source code, what's the revision you want to use, and what's the branch you want to use, that you defined in the XML file, so this XML file will clone the respective source code into your system, and it will be there. So in the in the Yocto, we have two different concepts like shared state and downloads cache. Two caches will be there. Like one is like a shared cache and downloads cache. So suppose in the downloads cache, all the source code will be placed here, and after the bitbake gives you an important feature that suppose if you made some changes in the download cache, like in the source code anyway, suppose if for the kernel, if you just made some change, so if you just compile the change, and if you just added that to the bitbake.bb append file, so the changes will be here, and the patches also you will be added here, so that these patches, when you add this patch, and if you just bitbake that kernel itself, it will be included. So it's a minimalistic change you are doing here. You just give one command like bitbake Linux. So suppose like bitbake Linux, or bitbake some recipe name. So it will compile everything for you. Just one command you are running here to make your job easy. Whereas here, you have to clone some repository, for U-boot, you have to clone one repository for kernel image, and you have some other repositories for rootfs, even for the hardware to enable, system.bit. For that one, you have to, clone some other repositories, organization specific repositories. So all this stuff you have to do manually. So it will consume a lot of time, and it will create a lots of confusion in terms of going for the conventional method. Wherein it comes to the Yocto, if you define what is the version you want to use, what is the revision you want to use, what is the branch you want to use in the XML file, uh, just with the environment sourcing for the bitbake, it will clone all the directories, all the repositories for you into the downloads cache, and it is one job. It is only one time job. Okay, so if you just give one command to build the whole artifacts. Arey yaar, someone shut their mic off. Okay, this is how the Yocto embedded, customized Linux we will be building using the Yocto build system. Okay, Ravi,
Yes, sir.
I'm not. Is that Ravi asked this
Prem,
question?
Prem.
Prem. Okay, Prem. So I just gave you the top level understanding regarding this. So we have planned a detailed context regarding the Yocto again for the people who wants to join, who have cleared the interview and all. So we will provide the detailed context regarding the Yocto. We will make them to build the images, each and every artifact by cloning that, and we will, that will be cloned and that will be built on top of it, like and the wiki images will be created, and we'll make them to load the wiki images for the boards that we have here in the ProV Logic. That is how it works. So if you are interested in terms of learning the Yocto, like it's a very quick and straightforward thing. So it depends on the intense, the thing is very intense